klik červený, ale keď som sa ho dotkol, píše, že zapnutý v inej miestnosti. Hej, VL7, aha, VL7, jasne, VL7. No ten vyzerá byť... To červené tam je takto. Dobre. Aha, jasne, dobre, vyriešené, ďakujem. Nazdar. Okay, so welcome to this ninth lecture in software architecture. I guess we should have some the most important questions at the exam will be from this lecture. So distributed software architecture is our topic today. After some excursions to other topics, we are back to patterns. So let's think, first of all, you don't have to think much about patterns at this initial moment. Let's think for the moment, why do we need distributed software systems at all? What's the point in having distributed software systems? I mean, you could do most of things you need locally. If you have sufficiently powerful computer, maybe that's one point. Maybe you don't have sufficiently powerful computer. Those resources are somewhere else, so you need to interact with distant servers in order to make your computations, whatever kind they are. Then it might be that maybe you need to develop and maintain your software system in a distributed way. So your team is distributed, so it might be logical to have things also located as your team members are. You might need to reconfigure these things as needed, so you might even think of some advanced things as a software-defined infrastructure, but we are not going that deep in this lecture. Anyway, it's a kind of remote collaboration that you need, and the question is whether it is a collaboration of systems, whether it's a collaboration of people, in order to get somewhere, to achieve some goal together. If you have people, let's forget about machines for a moment. If you have people, do you like collaborating with them locally or remotely? Or do you prefer to collaborate locally? No matter how advanced systems you use or to transfer your image, voice, or whatever, there are so many aspects of direct communication when people are together that we are not probably it's not even explored that deep. What comes into play there, and these might be slight not that noticeable, or things that we do not consider important until the moment comes that we are deprived of them. So normal human contact, so that you can see, right, like really people that you talk to and feel their presence, physical presence, is something that affects the other ways of communication, the other aspects of communication, those that like just conveying messages to other people, difficult. So it's a kind of, maybe with people, a psychological thing. With machines, it's not that psychological, but in the end, those machines are programmed by people, so it's a psychological thing when you need to call something that is dislocated, that is remote to you. If it goes over a network, then sure it should be the syntax for contacting that object or whatever it is would be different, wouldn't it? Wouldn't it be? So it's not the same if it would be local. So what you want from that communication is to look like local, because this is the simple way that you're used to. You might be aware that you're communicating with distributed components, but in the end, it's a thing that does not have to take your time. And as I said, the same holds for people and for systems. So let's look, we are not going to talk about how people collaborate. We talked about that already, but about systems. So how this collaboration of systems can be realized? What are the possibilities? What is a software system anyway? Or software system, it says software system, but what is a program? Do you know? What would you say? What are the main things that you deal with when you're programming? What do you do? There needs to be some functionality, and then we talk about, if we want to be wise, we say algorithms or neutral. Like, it doesn't have to be even algorithms. Do not have to be programmed at all. So we can have algorithms that are not and algorithms existed before computers came. So a more general term for functionality is algorithm. What do algorithms do? They operate on data. So you might have across, I don't have, this tablet is not working, so I cannot write. I can use words though, but it doesn't really matter. So for just this one thing that I want to say, that you might have come across the idea that a program is algorithm plus data structures, or algorithms and data structures. Data structures and algorithms is a course that we offer imposed on you during in bachelor studies, because it's a compulsory course. So Niklas Wirth came with this idea, and it's actually a title of his famous book. It's a very old book, I think, from some 60s, 70s, something like that. So some 50, 60 years ago. And it still holds. So when we think about program, okay, we can discuss this like from a more philosophical point of view, and where are the people there. But for this moment, it's quite appropriate to think about programs like this, because when you think of this question, how can collaboration be realized, you can decouple these two perspectives, the functionality perspective and the data perspective, or algorithm and data. So maybe the easier way to go is to collaborate over data. I'll do something, I'll change some things, then hand it to you, you change some things there, and get it back to me so I can advance this a bit and then hand to somebody else and so on. Or we will approach the table and or blackboard. That's one way to collaborate. You have, and it you might say that it is a kind of a pattern, or it is a kind of a structure that enables to collaborate. Different systems process data and put it on in a shared repository. And this is actually, shared repository is one way to go, for sure. Maybe we can say shared database. So it can be located at one node, and your processing units may be located at different nodes and accessing this shared database. A bit easier way to go even, so you don't have to even to think of a common structure, you can have a file transfer. So I'll do some things and then transfer the file to you, just as I explained previously. This is collaboration over data. But this is not quite calling some other process or algorithm or procedure or whatever somewhere else to do something for you. And we need that perspective as well. But it might be a way to go for some applications. And actually, it has the quality of a pattern. There are these two contradictory forces in a conflict at work, and this is the solution. So different systems need to collaborate over distinguished data entities, but they cannot communicate directly. So this is the thing that we don't have the ability, or for I don't know what reasons, but there might be different reasons that we cannot or do not want to communicate, have them communicate directly. So the solution is, as I said, roughly, keep the data entities in a shared repository so that each system can work on them. And as I started explaining, this is not the exact way that we might imagine the more elaborate collaboration, which goes through functionality. So this is a scheme that I was showing to you at several occasions, I think. In the middle part, you see this concept of broker. So the thing is that when you have this, and these are layers, but the layers are dislocated from each other, and there's network between them. So the two layers, this presentation layer and business process layer, run on different nodes. And the thing is that here we have this warehouse management client, or like warehouse management in effect, and warehouse management implementation, warehouse management client. These are different actually clients. This is actually some kind of a proxy that prepares everything to go through this broker, but there are different components here that actually implement these. This is actually an interface, and this is its realization. So these northbound gateway 2 times. I don't know why. Maybe the different currencies of the same thing. I'm not sure what Bushman meant by this, but these are components that realize this. And then what we want is to have this processed, but the business process layer. So this is the presentation layer through which the communication to the system goes from the user side. And we want to have this eventually. We want to have this processed, but this is on the business process layer, and which is on a different node physically. And this warehouse management implementation would have needed to be contacted directly without this structure. And this structure with these 2 brokers. So this is client-side broker, which requests something, and the server-side broker, which processes that request, actually hide away the complexity of establishing this connection and collaboration. So this warehouse management client proxy and this warehouse management implementation, they don't have to worry about the complexity of this of the communication. Just to remind you of this pattern, so broker, remote components in a distributed software system need to communicate, but this is complicated by technological dependencies. And then we introduce a set of brokers to hide technological dependencies, making remote component communication look like the local one. This might have reminded you of something that's called remote method invocation, to be aligned with object-oriented terms, but usually we talk about remote procedure call, which is quite an old thing, and what was behind that always was to make impression of a local method invocation. Although it does not as much as you can. Sometimes it does not look that pretty, but the idea is to not to have so much trouble around this. And we are talking now about not about collaboration over data, but collaboration by invoking functionality. We had there in this figure that I presented just a moment ago the client and the server side. And this is something. This is actually that client-server concept, which is being sold as an architecture. So, but if someone says client and server, then we may ask, how do they collaborate? So it's not just that, okay, let's have a client, let's have a server, and it will work somehow, and this is our architecture. So it's always that something plays the role of a server and something plays the role of a client, and sometimes this is a kind of like interchangeable in some cases even. So the components take a role of in one moment of a server to serve something, and then they switch sides. Sometimes this is stable. So anyway, if you have clients and servers distinguished, then we know that clients send requests to the server. And the question is, does the server need to contact clients? If you think of how to organize this. You all know about this pattern. Observer. So when you have an observer, your subject that observer objects are observing is not aware of who are exactly, or what kind of observers are there. It does. One thing is that it really does have to maintain a kind of a list or some structure, to store the connections to the observer objects, because it needs to notify them upon a change. But it really does not do much or do mess very much with them. But this is one little obstacle that we could use this pattern to decouple client and server to some extent. However, we have this kind of coupling that I mentioned, and it might be more appropriate to use something like this. Publisher-subscriber. It is a kind of a actually, I was puzzled by this idea when I first saw it, and was wondering why don't we talk about observer here? But actually, when you look a bit closer to it, although there is a subscriber and that publisher, which actually is your subject, so subscribers are observers. In order to, the idea is that subscriber components have to receive information from publisher components, but they need to remain fully independent of each other. Fully independent of each other. That's the key. And for this, you need a third thing. A propagation infrastructure which subscribers can connect to using which subscribers can connect to publishers. So it could look like, if we would stick to subject observer, it could be something like subject observer propagator, so that we free our subject from keeping the contact to the contacts or the contact information or connection to observers, and pass this responsibility on this third part that we would call propagator, something like this. Not that actually this pattern has been identified under this name. I just made it up just to compare or like let's say compare or make closer this explanation of publisher subscriber to observer. So this is not the actual name of the pattern, but maybe it could be the name of this pattern. However, one more thing is here interesting, that the context here, this pattern talks about components right away, and it gives a sense, an infrastructure, and it gives a sense of something something happening like in a distributed way. And actually it was meant like this. So this change propagation infrastructure is meant to be something that publishers and subscribers connect, and then this change propagation infrastructure hands over what is necessary to where it is necessary to go. So this is one idea and something that could work. We could imagine different implementations of this, but the important thing is to understand that, or to get to this idea. So despite it might look terrifying that you would need to implement all this, but when you have no idea, it's even worse. So one way to go is like this: to have publishers, subscribers. But what are these, and who is a publisher, or what is a publisher? What is a subscriber? Can't my object or my component at one moment be a publisher, and in the second one a subscriber to something? Or can it be just a service that needs to communicate with another service? So we can forget about publisher subscribers. So there are limitations to this idea because we have to make some decisions on the roles, or like the roles that our components take in that architecture. In the publisher subscriber architecture are kind of have to be decided and maintained like that. There is no idea of switching the roles there. Or you can always make a new instance of a component, of course, and change this and so on, but it's not that flexible as it could be with having just services that need to communicate. And for this, when you want to communicate, you just send a message. That's one way of communicating that is applicable even to us people, and we often use messaging, including email. And for computer components, it could be maybe the only way to go. So you need to pass some information. You can call it information. You can call it whatever you want. But in the end, you will need to pass something. So what is a message? You can think of it, but in if we base our architecture around this, it will resolve this conflict of these contradicting forces of independently, that say that independently developed services a distributed system consists of must interact reliably, but they are unaware of each other's specific functional interfaces. So how to make this communication reliable when these participants in the communication do not know each other's specific functional interfaces? I mean, you could have components that one component provides an interface and the other one calls that interface, but that's not what we want. It's not flexible enough. We can think of many different situations that we need to modify this. Once you introduce this interface in terms of software construct, like in Java, this is pretty much static, unless you use some meta-programming facilities and something like that. So you need to make this dynamic, and the interface is just here to get and send message. And this message will include whatever is needed. So the solution is to connect the services via a message bus that allows them to transfer data messages asynchronously. And then you need to encode the messages so that senders and receivers can communicate reliably without having to know all the data type information statically. What does this say is that this message bus will not care about the content of your message, just who is the receiver, and the interpretation will happen on that side. Plus, you would probably need to indicate somehow what is the meaning of the data. So the data scheme should be carried out by the message itself. This can be more or less elaborate. You know about XML as a markup, as a way of marking up things. So you can easily mark up your data with this meta information. So when you transfer somebody's name and first name, last name, and phone number, so you indicate these things, and something on the other side may recognize what these things are. But if there is only somebody's actual name and somebody's phone number, and you don't say, and it's in this order, and you expect somebody to guess on the other side that, yes, this is a person and this is their name and phone number and everything, that's probably not going to happen. So there is a whole way of things that you can, and then other patterns connected to this that enable you to elaborate on what really a message is. But the messaging system looks somehow like this, schematically. So just the message bus and service, 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 service. Okay, so does this remind you of something you saw? Not in your life, I mean, but in a few minutes ago. How different these two schemes are. So this is our publisher subscriber, and this is our message bus or messaging. So the difference is, what do we mean by this change propagation infrastructure and how the connection happens. And this is just a bus, so they are just putting the messages there, and whoever needs that message, they pick it up, or there can be different ways of passing messages. Then we will talk about message channels, and this is yet another pattern. And some message channels can be like propagating the information to all services. Some may be propagating messages to particular services where the connection is established, between which the connection is established, and such things. However, it's quite interesting that topologically these two schemes look almost identically. I suspect that they even use the same graphical structure, like the same diagram, just change the names of the parts. Yet, if you, both figures are from pattern-oriented software architecture by Bushman and colleagues, and there is no connection explained between these two patterns directly. So these are like alternative ways of resolving the problem of having your components distributed or your system distributed. So I just found it interesting that there's so much alike, but the real difference is here in this. What do we mean? How these components are connected, and that these are services. So these are all services. It's not said that one is server or client or whatever, or publisher or subscriber. So they can interact. So my service is connected to this, sends and receives the messages. It is not a less service or a different service, like it's a more, these services are more like peers. They are not distinguished in their nature is not different, or status. Their status is not different. The message channel that I mentioned more precisely could be defined like this. So the problem is that messages need to be delivered, but they should be independent of the routing information. And the solution is that a sending service knows who it wants to send a message to, establish a message channel between the sending and the receiving service. And then you don't have to care about the routing information in the messages. So you always you don't have to. It's something like with what we have in computer networks: connection-oriented communication and connectionless communication. And this is more like connection-oriented communication. Connectionless communication is where you just send packages, and the packages know where to go. The channel is something that frees your packages or pieces of information from having to know where do they have to be delivered. Sometimes it's more flexible to have this connectionless way of communication, of course, in networks. But we are not directly talking about computer networks. Now I'm just making an analogy to these two ways of communicating in computer networks. Are there any questions, anything, any remarks or ideas, comments so far? How to go about this, or what to do? You might decide to implement your own things, but there's bunch of distributed architecture frameworks available. Sometimes they're called middleware or message-oriented middleware, and some examples include Microsoft message queuing or Jakarta messaging. SOAP is an older thing, Simple Object Access Protocol, yet also falls into this category. I might add some of your own. Roughly, but there is a choice. So why would you implement your own thing? These things are not that simple. So you need to understand the comprehension is a problem. So sometimes we rather create our own things because we build the understanding as we go, as we build a thing. When we get a complex thing that we need to deal with, we need to analyze it and to get to understand it. Okay, you don't have to go into all the details of these frameworks, but you need to understand them. Probably you wouldn't go about this by building your own middleware. There are so many things you would have to take care of, but then you might ask, why do we need to study patterns then? Maybe that's why the colleagues that did not come to this lecture decided not to come, because they knew that, well, they have already available solutions to this problem, so they don't care about patterns. Is there any use of patterns if you do not build the thing yourself? I mean, if you try to open any service-oriented architecture as well and such things, try to open any of these books and to read them, to read the explanation, or try to read some manuals or whatever accompanying information comes with such software. And you'll see that you will be overwhelmed by details. You might say, okay, but we need the details in order to understand fully how to use these things. Yes, but you can always refer to details and use them as you go, as you need to write some piece of code precisely. Then you get to the details and use them. And when you get used to them, you will be fluent, and maybe you won't need so much of those handbooks anyway. But it's difficult to understand the principles, or not just principles are principles. The principles is maybe let's have a client and a server, but to understand what's roughly or substantially going on. What's the problem that is being solved? Why is this happening? Why is this established like this? What's the use of this? What's the purpose? Is this applicable to my context at all? And then suddenly it starts to make sense to talk about patterns, because this is the missing point. How these approaches are being presented, and I've seen this many times at conferences, PLOP kind conferences, Pattern Languages of Programs conferences, either American PLOP, Europlop, or there are several other conferences like this. Some are a bit on hold, but there are many papers that the authors, maybe mistakenly, I would say, just present these papers as being like as reformative information on what is known about something and provided in a pattern form or format. It's not just a question of a format. I think these are whole pattern languages, and the information provided there is just like in Bushman's book. So you can make consciously design decisions and put things together based on this, and you will know why you did this and when you did this and how, and the rest is just a matter of simple programming, as we say, but you will not be lost in this. And it shows that so many times that how useful it is to provide this information in this way. Maybe if you don't do this, you will do many things that you do not need to do, and then you will produce waste. So that you will need to, not just that will pollute something, but you will need to deal with that waste because it will be in your sight and distracting your attention. So that's the place for patterns still there. The other way to say all this that I said is here, to be able to select appropriate mechanisms, to decide what kind of distributed software architecture you will have, and to go after it and implement what you need. Let's look at yet another way to organize distributed software architecture, called pipes and filters. Pipes and filters is something that you know from Unix-like operating systems, but this is also available in other operating systems as well. I think it wasn't quite available until recently in Windows, but now you can have a pipeline of commands, each of which are passing what they processed to the next in a row. And there's even that symbol, that letter, like symbol character that is called a vertical line, which is called a pipe, which is used to decouple these segments of your complex definition of an operation that you need to execute. The idea, this idea can be applied to components as well. So you will have the situation that data need to undergo a complex transformation, but the steps of this transformation are meaningful on their own and can be arranged in different ways. So the idea, the solution is to realize the transformation steps separately and make them connectable to each other over the data they produce. So it's not the question of just having this kind of shell system that or prompt that you provide your comments to, and then they are executed. That these can be components. So the components are connected by something we call pipes, and these components are actually considered to be filters. So they filter somehow the information. Maybe this notion of filters is not quite right, because the processing might not be just filtering, rather a transformation. But for historical reasons, the name stuck simply. So pipes and filters. And we could think of something like having pipes and filters over messaging or composed with messaging. So the messaging could help us establish particular channels between our filters or components that need to be connected. So it is possible to go with this if you have this more modern framework or middleware for messaging, and you need to organize things in pipes in this pipes and filters fashion. You could do this around like this. So this is roughly it from my side. What we saw is that parts of a distributed software system can collaborate over data or by invoking each other's functionality. And that invoking the functionality and passing data between the parts of a distributed software system can be decoupled into a messaging mechanism. So these are roughly two ideas. I presented you with some of the patterns that are related to this. But I didn't want to overwhelm you with the details of what kinds of channels there can be and such things. So or what kind of the structure of messages is also treated by several patterns, so on. So these are the starting points, and I think it's interesting to compare the patterns that you read about even in a different way than different ways than the author assumed they should be. So there could be some further relationships discovered as well. Any questions, notes, comments? Okay, I made this lecture a bit shorter, so we have time to discuss whatever you might need to discuss regarding the course. I guess for those who are here, everything is clear. I have a fresh information on the date of the exam. So it is scheduled for December 19. December 19, if it's not, if it, well, it still could be changed, but I assume it was set to some other date before. So this is a changed date already, so I expect it to stay like this. So December 19, maybe this information has been already published to you. I'm not sure, but maybe not. I don't know the time, just know the date. So because I did not specify exactly the time in my requirements. I hope it won't be too early in the morning. Okay, do we need to discuss anything in particular? No, I think I deprived you so much time on several occasions that so I can give back some time to now to compensate for that. We will meet next week, probably at the same time. There will be this lecture. I think the schedule is that. Is it that guest lecture already there then, or no, maintaining? Yeah, I was thinking about aspect-oriented modularization, but this is I knew that this comes after this guest lecture on container-oriented software architecture and its implications. So maintaining software architecture. So we'll remain with patterns and anti-patterns. Patterns of how not to do things, maybe, or bad smells and such things, so-called, in code, and how to go about them in this lecture next time. And then on November 29, we have this guest lecture on container-oriented software architecture, and this is something. Well, containers are there, are highly related. Actually, a thing that is or a mechanism that is used in distributed software systems. So it will be interesting to hear from Marko Ranković, who is Deputy General and the Executive Director at Regional Card Processing Center, Raiffeisen. How this is to think for a moment how the things that he will be talking about are related to distributed software architecture. Okay. So that's it. That's where we are. And on December 12, we have one more time slot for a discussion. If it would be necessary, if there will be no things to discuss, then we will skip this one. We'll see. I guess you will have enough trouble finishing all the assignments that you need to submit by the end of the teaching period. Okay, so no questions regarding this either? Doesn't seem so. Okay, thank you for attending the lecture. See you next time.